Hello, everyone. This is Zakia Sultana, an 18-year-old IEL high schooler from Sylhet, Bangladesh. And it is with so much excitement that I will share today, discuss my experiment with you guys on magnetic field lines. Can you go to the previous slide, please? We'll come to this later. Yeah, okay. So I'm going to share with you, discuss with you my experiment on magnetic field lines, particularly in the unusual microgravity condition aboard the ISS. But before that, I'd like to discuss how I actually came across this idea. I think so. It's being played on. Is it all right if I share this presentation? Sure. You know, I would click and go steer the presentation as I explain it. Okay. Okay, thank you so much. Can I get the permission to share my screen?
Okay.
Thank you.
Hold on for a second.
Sure.
Yes. Please show your slide.
ホスト渡したホスト券渡した
しない。ホスト券渡すな。あ、マニアの動線たちの。
Okay, you should be able to show your presentation.
Okay, sure. Thank you so much. Yeah. Is it visible?
Yeah.
Okay, I'll start. Hello, everyone. This is Zakia Sultana, an 18-year-old IEL homeschooler and a full-time teacher from Sylhet, Bangladesh. And it is with so much excitement that I will discuss my experiment on magnetic field lines with you guys today, particularly in the unusual microgravity condition aboard the ISS. But first, I would like to describe how I actually came up with this idea. So I always thought about science as the most beautiful magic that we have. And the more I grew up and learned about both life and science, I saw how much interconnected they are to each other in those graceful patterns of those magnetic field lines, reflections of our own journey through life. And just as magnetic fields take on different shapes and forms, our life is also molded in a very similar fashion by different circumstances and experiences. Much like how magnetic fields have strong and weak points, so too our strength ebb and flow. We all have our positive and negative sides to who we are, much like how magnets have polarity. But perhaps the most profound similarity between us and them lies in the polarity reversal. As we know, magnets can change their polarity depending on certain situations. And I think our lives can do the same when we come across drastic changes. In darkest moments, when all this hope seems to be lost, this ability to flip our internal compass and give our life a new direction. In this presentation, I will be discussing the factors that will be affecting the magnetic field lines, and then go through the experiment materials and the experiment procedure, and then finally finish it off with the hypothesis and the expected results. Okay. Going on to this following slide, we can see that magnetic field lines come in a variety of sizes and shapes. The first factor influencing this is the magnetic fields of celestial bodies such as the sun or other planets. Any item nearby will typically experience distortion and alteration to its magnetic field as a result. The second one would be strong galactic magnetic fields, which have the ability to significantly affect both the alignment and the magnetic field lines in the interstellar space. And this would be our second contribution. The third variable that may alter the magnetic field lines would be plasma interactions, which would lead to complex dynamics, and the magnetic field lines, the plasma interactions actually make the magnetic field lines becoming more band twisted or more turbulent. The next one would be interplanetary magnetic field, which interplanetary magnetic field, which can cause various distortions to our magnetic field lines. And lastly, stellar winds or supernova explosions is another affecting factors of the magnetic field lines. The expanding shells of the gas and dust left behind by supernova can actually interact dynamically with magnetic fields, generating complex patterns of magnetic turbulence and acceleration of charged particles. Conducting this experiment, I am to observe the differences in the formation and behavior of magnetic field lines compared to that in a standard Earth-based environment. Moving on to this slide, we will discuss the materials required for conducting this experiment. The first item on our list is the bar magnet, which serves as the primary focus of the experiment. The next essential object we have is the magnetic box, which contains iron tips and features a compartment designed to accommodate this bar magnet. Now, let's move on to the procedure for conducting this experiment. To begin, we will take the magnetic box, which has a length of 10 centimeters and contains iron tips, and insert the 5 centimeter long bar magnet into the designated place within the box. Once the bar magnet is securely secured in that place, we will proceed to rotate the magnetic box a full 360 degrees. This rotation will allow the iron tips to arrange themselves around the bar magnet, aligning with the magnetic field lines and giving them a distinct pattern. Now, onto the hypothesis. As we know, in the Earth's gravity, we use a simpler bar magnet and iron filings on a piece of paper to just visualize the magnetic field lines and see it align from the North Pole to the South Pole. However, in microgravity, like the International Space Station, the iron tips would suspend and disperse randomly around the magnet in 3 dimensions. External factors that we have already discussed earlier, such as celestial magnetic fields and plasma interactions, further complicate this shape of the magnetic field lines, making them more dynamic and intricate. Thus, visually representing magnetic field lines in microgravity using iron filings becomes very challenging, as clear patterns like those on Earth won't form. So we remain uncertain about the exact shape of the magnetic field lines in microgravity, until the experiment is conducted, which is exactly why I chose my experiment for it. Coming on to the end, I would love to thank JAXA for creating this beautiful event for us to learn and explore. And my heartfelt gratitude to Mr. Mizanul Chaudhry, Saba Chaudhry, and the entire STEMX365 team for bringing this opportunity to students interested in the STEM fields, such as myself. This dedication for fostering curiosity in young minds is definitely commendable. Lastly, I would like to thank my mentor and an amazing, awesome human being, Irfan Nafiz Shahan, for always striving to instill in me the passion for growth and learning. Thank you so much for telling me that you would believe in me, even if I were to simply exist. This is for you. Thank you, everyone.
Any questions? or comments? Okay, right.
マイク持ってかなくて大丈夫なの？
Okay.
Hello, can you hear me? Zakia?
Yes.
Okay, thank you. Thank you for your presentation. Oh, hello.
Hello.
Just a question about your experiment. Do you think the magnetic lines that you would see in your experiment, would you expect them to be static, or would you expect them to be shifting dynamically depending on the movement or the external forces interacting with the ISS?
In no way I would think that like they would have an exact shape. I mean, they would be changing constantly because depending on the circumstances, because a lot of factors affecting them. And as per my hypothesis, I really think that they would shift dynamically as we have a lot of factors affecting them. So yeah.
Okay, thank you very much.
I hope that answers your question.
That was fantastic, thank you.
Thank you.
Oh, hi.
Okay, he has another question.
Hello again, sorry. Also, what application do you think this would have in terms of navigational technology or even living organisms which rely on magnetism to live, like certain bacteria use magnetism, some rodents and birds use magnetism. What effect do you think this would have on them if you could kind of map or see how these lines shift, how the magnetic fields shift?
Well, I'm not 100% sure of how it would, be. It would change our future view to magnetic field lines in the space. But I'd say that since magnetism is a big factor affecting the entire universe, right, from the core of the stars to everything, to the creation, we have magnetism there, electromagnetism, whatever it is. So in order to know how magnetic field lines act around an object in the space, I think that would contribute to a lot of things becoming clearer for us when, let's say, for how, an instrument would work with a magnetic field line around it if we send it to space. Any instrument, any sort of thing. So yeah.
Okay, very interesting. Thank you.
You're welcome. Thank you.
All right, thank you. Okay, any other questions? Okay, all right, thank you.
The next experiment is magnetic field experiment proposed by a Bangladesh student. Okay, look at the behavior of these colorful tips. Okay, I'm coming to the side. They are floating, 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 floating. And if I apply force, they move accordingly.
do magnet experiment now.
Okay, now I'd like to put the magnetic object. Okay. Okay. I'm inserting this. Okay, first look at it here. I'm inserting this.
Satoshi is on, so we have a little correction, so you're ready to come.
Go ahead on forward, Tommy.
Use the purpose for about that, I'd like you to use magnet with Kappa tape because without Kappa tape we cannot take out the big magnet from the box.
Okay. Okay, from the side, please take a look at what happens. And then I'm inserting this. Now the magnetic is totally inside. Now here's a view from different angle.
And Satoshi onboard thanks the perfect view that you came on to message Kibo Module 67865.
Copy. All right. Okay, that's all for this experiment. I'm looking forward to your analysis and discussion.